Hi everyone, this is a video going through the notes for the Nat 5 Trigonometry 2 section. The good thing about this section is everything that we do is included within your formula sheet. Okay, so you can see there are three things up the top here, which are the area formula, sine and cosine rule. All three of those are within your formula sheet, so you do not have to remember them all. And the process is the thing that is important here. So the first thing we need to get really good at is naming triangles. In order to use the sine rule, cosine rule and the area formula, all three which are given in the formula sheet, we have to use a consistent way to name our triangles so that we know which side angle is being found. So we tend to name our sides with smaller letters, and they are then opposite the angles with which we use larger letters. So in this triangle here, angle A is on the left hand side, through the triangle takes us to side A. Angle C is down the right, through the triangle takes us to side C, and with angle B through the triangle takes us to side B. Those angles and sides are corresponding, and we have to make sure that we have them labelled properly. Not necessarily in a particular order, but that angle B is across from the side B, angle C across from the side C, and so on. Okay, so let's see how we can actually use this then, once we've labelled our triangle, how we can start to use these formulae. And the first thing we look at is finding the area of a triangle. Now, of course, we are used to finding an area of a triangle when we have got a half base times height. Okay. However, at Nat 5 level, we are not going to have the height, we're not going to have the base, but we will be able to use the formula that is in the grey box here. And as I said, it is given in your formula sheet, you do not have to remember it. Now, the sides, A, B and C are the sides, A, B and C capitals are the angles. C is always the angle that you are given, and A and B are the two sides that are formed together to create that angle. So I've got two examples down here that are slightly different than what we might normally see. When you come to do the booklet questions, you'll see more straightforward ones. But let's have a look at these ones to see how we can apply the formula. So example 1, part A, we've got an equilateral triangle of side 4. That tells me that all sides are 4 centimetres, and it also tells me that all angles are 60 degrees. It's an equilateral triangle, all angles add up to 180, they all have to be the same, so they have to all be 60 degrees. Now, for this triangle, it doesn't matter which way you label the sides. So we're going to say A, B, B, and C, C. Now, the formula then, we're looking for the area of the triangle, a half A, B, sine C. And with this formula, similar to mode and volume, it is a case of plug in the numbers. Once you have labelled the triangle, if you have labelled it correctly, it should be a simple process. So we've got a half times, well, where's A? 4. Times B, which is 4, times sine of C, so the angle C, which is 60. Now, all of this can go in your calculator. 1 divided by 2 times 4 times 4 times sine of 60 equals 6.9. We'll just take it to one decimal place. We are looking for an area, so it's units squared. Now the units are here, 4 centimetres, so it's centimetres squared. Now the next one is the same process. We are still using the same formula. In this case, I only have two sides of the triangle, so I'm going to label those two sides A and the B. Right, let's get rid of those labels first of all. Okay, the labels here are just going to confuse us. We're going to get rid of those just now. I am going to label the sides that I have A and B. It doesn't matter how you label these sides as long as you make it corresponding to the actual side, so it's proper. B, angle B is across from side C, angle A is across from side A, and C is going to have to be in that position there. The reason that I've labelled it this way is because now both of my sides, A and B, I have numbers for those. I don't have an angle at C, but I can find that angle. I will need to do 180, take away 70, take away 43 to get that angle. Angles in a triangle adds up to 180. This is not something that's new to you. We're assuming that you know that. Therefore, the angle up the top here is 67 degrees. Putting in what I have then to the formula, it's a half times by side A, which I've labelled as 7.2, times by side B, which is 4.6, times by sine of angle C, which is 67. Put all of that into the calculator, round it to one decimal place. And we will get 15.2 metres squared. Again, we're working with area of the triangle. Our units are in metres, we have to use metres squared. Now, let's have a look at the next one. So this next one here is a non-calculator. We're still using the same process, but it's a non-calculator question this time. Again, get rid of those A, B's and C's. They are just going to completely confuse us, and whoever made these notes was a bit silly with putting those letters in there. Okay, so we are told that, so we're given a load of information at the top here, but we're also given a diagram. And what we're going to use is only use the diagram just now. So label the sides that you've got as A and B. That way it makes sense when you put it into the calculator or into the formula. The angle then that we are given is in between those two sides, A and B, which means that angle has to be C. And if you label them A and B, the only other option is to label that one C. So we are trying to find the area, which is a half AB sine C. So a half times 8 times 6 times sine of 30. Now the reason we can do this without a calculator is because up in the question, that blurb at the top, we are told that sine 30 equals 0.5. So the next thing I can do then is say, well, that's a half times 8 times 6 times 0.5. Okay, the reason that being sine 30 is 0.5, so I can swap those two around. You wouldn't ever be expected to know that, but it tells you up at the top there in the question. From here then, I will do a half of 8. Let's do that bit first. So it becomes 4 times 6 times 0.5. 4 times 6 is 24. Times that by 0.5. Now here the trick is to know that 0.5 is the same as a half. So essentially what I want to do is half 24, which gives me 12. And our units were metres, so 12 metres squared. Okay. As with the volume questions, if you have to do a non-calculator question on these, then you'll be given easier numbers to work with. Okay. Now, you will find questions on this. If you're following the lessons, then we'll be doing it during class time. But if not, then you'll find questions on this in the Unit 4 booklet on page 26 until 26, 27, 28. So 26 to 28 you will find questions. I will pick specific questions for you to do when we come to do this during class. Okay. Moving on then, we are now going to look at what's called the sine rule. Now, if you remember back to previous years, everyone, whether it was in Nat 4 or whether it was last year at some point, will have seen SOHCAHTOA. Okay, so that's using your sine, cos and tan to find either a side or an angle of a right angled triangle. When we don't have right angled triangles, we use something called the sine rule or the cosine rule. Now, these are used in different situations, and it will depend on the context of the question to depend which one of the rules you have to use. Right now, all of the questions we're going to do in this section of the notes are using the sine rule, so that thing in the grey box, and then we'll do the cosine rule separately, then we'll take them all together. So, the first question here, and with all these questions, I'm going to ask you to write down the formula first. Okay, so we've got A over sine A equals B over sine B equals C over sine C. Now you may remember back to when we did arcs and sectors, we had a 3-part formula and we chose which 2 parts to use. Well, this is the same as we have to do this time as well. First thing I'm going to do is label the triangle. So I've got then A over here, that's the side I want to find, which means angle A is across from that. Now you can choose what to label as the other sides. So if I label this one as B, capital B for the angle, and the missing one that's representing that as C's, then we can tick what we have in the formula. We are looking to find A, so we can tick that. We have the angle A, which means we will be able to find sine of that angle. We have angle B, and we have side B. So we are not going to use the C section of this formula. The next step then is to substitute in everything that we know that will allow us to find what we don't. A is what we don't know, so we leave A there. Capital A, I do know, so that's sine 35 on the bottom of that fraction, equals side B, which is 12, over sine of angle B, which is 78. Now, with this process here, it's very similar to what we did with the arcs and sectors. We can multiply up by the sine 35, and we can make then A equal to 12 times sine 35 all over sine 78. So that has been multiplied up by the sine 35, putting it onto the right hand side. Now, we can pop this into the calculator. I would tend to do the top of the fraction first, 12 times sine 35, hit equals, then hit the divide button. Divide sine 78. Hit equals again, and we should end up with 7.0 to 1 decimal place. It doesn't ask us to round it to anything, so we'll just stick to 1 decimal place. 7.0 metres will be our units. Okay, we're finding a side here, which is why it's metres as our units instead of squared, like we did with the previous notes. Okay, let's try another one. Again, it's a different context because we want to see a variety of these questions. So, we have side B over there, angle B is up at the top. We can label the other sides however we want, so I'll say this one side is C, which means that's angle C, that's angle A then, and C over that side. Now, in this case, I want to write down again the sine rule. Okay, and tick what I'm given in the question. So this case, I want to find B, so I can tick that, because that has to be part of my calculation. I am given angle A, so capital A. I am given angle C, capital C. I'm also given side C. But then we get to this stage, and I don't have two parts of the formula with two ticks. But what I can do with this question and with this triangle is find out what size angle B is. If I do 180, take away both of the angles inside the triangle, I will find out what angle B is. Therefore, I will have angle B to put into the formula. And angle B then is 57 degrees. So this angle up top here is 57. Having calculated that, I can now tick it, which means I want to use parts B and C in the formula. Substitute in everything that you have. B we don't know, so that stays as B. Capital B is 57, sine 57 equals, and then C, side C is 24, all over angle C, so sine 85. Okay, so you can see these letters are really important, and it really depends where they are on the triangle and what they correspond to for you to get them in the calculator correctly. So B then is equal to 24 times sine 57, and then we've got to divide that by sine 85. Please don't be thrown off with all these signs in here. It is simply a number. Sine 57 is simply a number. We can pop it in the calculator exactly as it says, 24 times sine 57, hit equals, then divide that by sine 85. We will get, in this case, 20.2 metres to one decimal place. Okay. Now, we can also use the sine rule to calculate an angle. So if we are missing, say, angle A, then we can use our sine rule to calculate that instead. So with this triangle, we are going to take all of the sides. You can see that angle C is the one that I'm missing, which means side C is with the 25. I label the other two as A's, so that's angle A at the 40 and side A at the 17. B's will be the other side and angle. I don't have either of those, so I'm probably not going to use them. Now, I'm going to ask you to alter the sine rule here, okay? You're not given the sine rule in this form in your formula sheet, but if we flip our sine rule upside down, so all parts, i.e. we put the sines on the top and the sides on the bottom, then that process is mathematically sound. We're able to do that, but it also means that we don't have to start cross-multiplying anything a little bit later on. So when finding an angle, we are going to flip the sine rule. A's are still with A's, B's are still with B's, everything's just on the opposite side of the fraction. Now, this makes life a lot easier for us. Tick what we have first of all, and you'll see why in a second. We want to find angle C, we have side C, we have angle A and side A. Therefore, we're not using B. Substituting that into the formula then, we have got sine, what's that? A is 40, so sine 40 over 17 equals sine C, which we don't know, over 25 for small c. Now, in order to get sine C on its own, what I'm going to have to do is multiply up the 25. So when I multiply up the 25, I end up with 25 times sine 40 all over 17 equals sine C. Before I go any further, I am going to swap that round. Make it sine C equals to everything that's on the left hand side. So all I've done here is swap the sides over. The only reason I've done that is because I prefer to work with it that way and have what I'm trying to find on the left hand side. Now the next thing we need to do then is to get a number for sine C. That would be 25 times sine 40 equals, then divide that by 17 and we get 0.945. Now I'm going to ask you to take that to 3 decimal places or keep it in your calculator. And the reason for that is that we have to perform a calculation with that first before we are finished. Sine C is equal to 0.945. To find C, I have to take the opposite of sine, which is sine to the minus 1. When I do that, I apply it to the 0.945 and that will give me my answer for angle C. So when we are finding an angle, the process is slightly trickier. Now to find this in your calculator, shift sine will give you the wee button of sine to the minus 1. Otherwise, you can use the online calculator that I will link in the Teams post. Now, I'll put the 0.945 into here, and the reason I take it to 3 decimal places is to have more accuracy in the answer. So the answer to 1 decimal place, 70.9 degrees. Okay. So that process there, sine minus 1, we'll get another little practice at it in a second to see how it applies to maybe a different situation. And that'll be this one here. Now in this case, we are given a different letter for to use. Okay, we're given D's here instead. Now that's perfectly okay. We can use different letters. We've got an angle in there. We want to find it. We will be able to do that. Now the process here to find this angle, I am going to first label the other side, label that with A's. Okay, I'll keep using the letter D, so the angle D and side D there as well, and we'll label the other one as B and B. Now, if I write down the sine rule, I'm trying to find an angle, so I'm using the opposite way around. This is where the different letters in the triangle can come into play. I have got letters A, B and D in my triangle. But in the formula, I've got letters A, B and C. All I'm going to do here is rewrite the formula with the letters that I have in the question. I've got A, I've used B, and the last one I need to have is D. Those letters have no significance. They are just a way of matching up sides to angles. So it doesn't matter whether you use D's, R's, P's, Q's, whatever, we'll see different letters coming in later on. But as long as you've got the corresponding angles to sides, then that's what's important here. So tick what we have then. We want to find angle D, so we tick that. We have side D, we have angle A, and we have side A, so we can tick all of those. Therefore, we're not using B in the middle, and we can substitute in all of our numbers. Sine A is sine 53 all over 78. That is equal to sine D that we want to find all over 85. Times that 85 up. And I'm also in this step going to swap the sides as well. So that will give me sine D equals 85 times sine 53 all over 78. Again, don't be afraid of those signs, just pop it into the calculator. 85 times sine 53, and then divide that by 78, and we get 0.870. Again, just take it to 3 decimal places so we have enough room for any rounding errors. Now, last thing to do then is to take sine minus 1 of 0.870. When we do that, we end up with an angle of 60.5 degrees to 1 decimal place. Okay, so that included quite a lot. One, kind of changing all the sides as well, using a different formula and flipping over the angles and the side. You will see questions based on the sine rule, and we will do one separately. One's finding a side and one's finding an angle. Okay, so the sine rule, finding a side, which were these questions here, will be from the Unit 4 booklet, page 29. Okay, and you'll find the answers on there. To find an angle using the sine rule, it will be the Unit 4 booklet, and that is all on page 30. Okay, so that's us use the sine rule. The next notes that we're going to work on are the cosine rule. Again, this formula is given to you, and we use this when we have a different scenario. So we have different situation in our triangles that we have to use this. We are not able to use the sine rule. Generally, this is used when we only have one angle. If we have two angles, normally we will use the sine rule, but if we only have one angle, then the cosine rule is the one to use. So as before, we have got to label the triangle. Side A is already labelled for you, so angle A is at 40. Sides B and C can be either of the other two, it's up to you. So I'll label them that way round, which means angle B is down here, angle C is up the top. Write down the formula as before, which is a squared equals b squared plus c squared minus 2bc cos A. Don't forget that c there, there's two c's, so it's 2bc then cos A. Okay, these a, b's and c's are not the same a, b's and c's we use with Pythagoras' theorem. That's only used with right angled triangles, which is why we're adding them together here rather than subtracting from the c. So substituting in all of the sides and angles that we have, side B is 18, so that is 18 squared. Side C is 21 plus 21 squared. Take away 2 times 18 times 21 times cos 40. That is everything substituted in exactly as it's supposed to be. B is 18, C is 21, angle A is 40. All of those things, 2bc cos A, means we have to multiply each of them together. Now this can go straight into your calculator. If you've got a scientific one, that's the best use for these questions. Otherwise, you've got the online calculator as well, which will do the same thing. So 18 squared plus 21 squared, put all of this in, minus 2 times 18 times 21 times cos 40. Your calculator will do the BODMAS calculations, it will do the section at the end, and then it will take away that from the section at the beginning. We should get then 185.9 for the answer. Don't clear that from your calculator. that is a squared. So the last thing to do to find a is to square root 185.9. Keep that in your calculator as whatever it is, so you can square root it to more accuracy. Therefore, the length of side A is 13.6 centimetres to 1 decimal place. Okay. The next one, we are using the cosine rule again. In this case, we're going to label everything just as before. So we want to find the size of side labelled B. That's our side here. So therefore, angle B is at the top there. Now in this case, you can label your sides any way you want. It doesn't have to be A, B's and C's. A, B's and C's are the letters in the formula, but what I'm going to do is I'm going to rearrange those a little bit. So for this one, the other two sides I am going to label as R for the 24, so capital R down at the 84, and T, so capital T down at 32.6. The reason I'm doing that is to show you that it doesn't always have to be in line with the A, B's and C's. They are just placeholders for different numbers, different letters, different values. So, if we write down the formula, then we will be able to substitute in the different letters before we substitute in the numbers. So that's our formula there. And let's see what we're trying to find. Right, we are not trying to find side A, we're trying to find side B. So the A's this time are in fact B's. The B's and C's are R's and T's. So it's the sides, the small ones for R's, R squared, plus T squared, minus 2RT, cos, not A anymore, it is B. So our A's have been replaced by B's, B's replaced by R's, and C's replaced by T's. That is before I've done any of the substitution with the numbers, just because I've got different letters there. So that's why I've used those different letters to show you how that would work. Before I move on here, I have to calculate the size of angle B. I don't know what that is, but I need it to calculate the side B. Therefore, I could say that 180, take away 84, take away 32.6 will give me angle B. Take away 84, take away 32.6, and we get 63.4. So angle B has to be 63.4. Now that I've calculated this, I can use it in my formula. B squared is equal to, so what's R? 24. 24 squared plus 13 squared minus 2 times 24 times 13 times cos. Angle B is 63.4. The good thing about this formula is it just goes straight into the calculator, like that. So 24 squared plus 13 squared, take away 2 times 24 times 13 times cos 63.4 equals, and it will spit out an answer for you. 465.59 and so on. Again, don't clear that in your calculator, just leave it there because we have to square root it to get our value for B. So square root answer in the calculator, 21.6 metres to 1 decimal place. Okay. Now that was the cosine rule to find a side. Before we move on to angle, you will find these questions in the Unit 4 booklet on page 31. Okay. Next, to find an angle using the cosine rule, we are given a new formula. So this formula here is given in your formula sheet. You don't have to start rearranging anything, doing the opposites, anything like that. It is given to you. Okay? So in this question, we want to find size of angle A, which is down here. The only way that we can ever use this formula is if we have all three sides. So if you're not given all three sides, you know it can't be the cosine rule to find the angle. If you're looking to find one of the angles and you don't have all three sides, you can't possibly use the cosine rule. So that's a good indication of when you have to use this, okay, for future reference. But in this case, we can label all these sides A, B's and C's. Write out our formula, cos A, and it's B squared plus C squared minus A squared all over 2BC. Now, all of these are numbers, which is quite handy. B is 16, 16 squared plus 7.6 squared minus 13.5 squared, all divided by 2 times, what's our B again? 16 times our C, which is 7.6. Now, the reason I have put brackets around the bottom calculation there is because that's how I'm going to put it in the calculator. Okay, and in fact what I am going to do is put brackets around both of these calculations. So, to put this in the calculator, you are going to do the top calculation first. 16 squared plus 7.6 squared minus 13.5 squared and hit equals. Now I think what I'm going to do is ask you just to write these numbers down. That's probably the easiest way. So it's 131.51. It won't ever be long numbers, it's normal numbers, it's just square and decimal, so it won't ever be too long. Then I'll do the bottom calculation, 2 times 16 times 7.6, which is 243.2. Then I will perform the division calculation and get a decimal out of this. So that gives me cos A, 131.51 divided by 243.2 equals 0.541 to 3 decimal places. Therefore A is cos to the negative 1, the inverse of cos of 0.541. You will find this in the calculator in the same way as you did the sine. Shift cos should come up with cos minus 1 and 0.541, pop that in and we get an answer of 57.2 degrees as our angle. Okay, so the calculations here are pretty straightforward in terms of they're just numbers, but you do need to make sure that you continue to put the calculations in separately and then divide your answers into a decimal at the end. Okay, so another one of these. We are given all three sides of this triangle, therefore we can use the cosine rule. Now, in this case, labelling a triangle, let's label with the one we want to find as A, and that will be A here. B and C can be the other two sides that we don't know, and then we use our formula. Cos A equals B squared plus C squared minus A squared all over 2BC. So, cos A, side B is 90 plus side C, which is 61, minus side A, which is 120, all over 2 times 90 times 61. So in this case, let's find our two numbers. 90 squared plus 61 squared, take away 120 squared, gives us negative 25,2579, and then 2 times 90 times 61 gives us 10,980. Now this being a negative number is okay. We'll make that then, what's our answer going to be? 2579 divided by 10980 equals 0.235, negative 0.235 to 3 decimal places. Now with this one, you're not going to see very much of this. If we think back to when we looked at questions before, with the trig formulas, we had to use our cast diagram. Okay, think all the way back to solving trig equations. This was 180 take away, 180 plus, and 360 minus. So we are using cos, it is negative, which means we have to use the two sections S and T. The first thing we have to do then is to do cos minus 1 of 0.235. We get an answer to that, and we perform our two calculations, and we decide which of the two angles would make sense when we put it into the context of our question. So shift cos of 0.235 is 76.4 to 1 decimal place. 180 take away 76.4, and 180 plus 76.4. So if we add 180 onto that first of all, we'll get 256.4. Take it away from 180, and we get 103.6. Now the reason I've done the two of these is because we've got to now consider which one would be viable. Look back to the diagram. There's no way that that angle there can be as big as 256.4. No possible way. The reason for that being is that all of the angles in the triangle add up to 180. Okay, and the angle that we can see there, which is marked on as X, is not as big as 276 or 56. It is also not as small as 76.4, so that's why we definitely know it's not 76.4. What we do know, however, is that it is 103.6. So 103.6 degrees is the answer to that question. Okay. Now, these specific questions, finding the angles, they will not be as tricky as that one there. You will find on page 32 of your booklet. Okay, moving on to some mixed examples. So this is where we have to decide which one of our formulas we're going to use, whether it's the sine rule or whether it's the cosine rule. Now, in this case, there are a couple of little rules you can think to remember. If you have two sides and an angle, then we are going to use the cosine rule. If we have all three sides with no angles, then we are going to use, and we have to find an angle, then we are going to use the cosine rule. So it says in the grey box there, always assume the question uses the sine rule unless it meets those two conditions. So if it meets those two conditions, then we might have to consider using the cosine rule. Okay, I'm going to stop this video here as the iPad's running out, and I will upload two separate videos. So I'll upload another video with the results for the mixed examples and the past paper examples. Okay.